In this video, I'm going to show you how concerned you actually need to be about moisture in your filament. I'm going to show you what effect it has on your print results, what you can do about it, and whether you can successfully revive damp filament. If you've been 3D printing for any length of time, then you've probably heard somebody say that you need to keep your filament dry. All 3D printer filament is hygroscopic to some degree, which means it absorbs moisture from the air. The degree to which it absorbs moisture is dependent on different factors, such as the humidity of the air, the temperature of the air, and the molecular makeup of the filament itself. Personally, I discovered the effect that moisture has on my filament when I started getting print issues with filament that I'd had in my garage for a little while. The filament I had started breaking easily, and I was also getting stringing, which I hadn't experienced before, and I'd made no changes to my printer. When a new roll of the same filament cured all my problems, I realised that something must be happening to my filament over time, and through research I discovered that the most likely cause was moisture in my filament. To try and stop this, I modified a food storage box with 3D printed parts and a desiccant container to try and make sure that my filament was never exposed to atmospheric air for any length of time. This solved 99% of all my moisture problems. The only moisture problems I've had since is actually filament being delivered with moisture already present, but that's a topic for another video. What we're going to try and see today is how much moisture might affect your prints and whether wet filament can be successfully brought back to life. The filament I'm going to use for this test is Silk PLA from Iono. There's no particular reason why I'm using this filament other than that Iono sent it to me for assessment and I'm working my way through it to give it a good test. Also, any surface defects are more likely to show up with a shinier filament. What I'm interested to see is whether PLA is actually affected by moisture, because there are a lot of people who will confidently tell everybody that PLA isn't affected by moisture at all. They say that it's not hygroscopic and moisture won't cause you any printing problems if you leave it out. My own personal experience is that that's not true, but I'm always ready to be proved wrong. I'm going to print a good old benchy at each stage so we can hopefully see any difference in print quality. I'll also measure the diameter of the filament at each stage so we can see any difference. I'll run you through the 4 different stages first and then give you the results. First off, let's print our first benchy when the filament's new and straight out of the box. Now we'll try and dry out any moisture that the filament may have been delivered with in a modified Sunlu S1 before our next benchy. I usually get between 2 and 4 grams out of a new reel, so it'll be interesting to see if there's anything here. Now we have a new and dried filament benchy, let's try and make some filament wet. I cut off enough filament to print a few benchies and then weighed it before submerging it in water. I then left this to soak for a week. After a week-long soak, I removed all the surface water with a paper towel and then wound it back onto a spare spool. I then printed our next benchy. The filament then went back into our modified S1 for a few days before being weighed, measured, and then turned into a little plastic boat. If you're enjoying this video, then let me know by hitting like and think about subscribing. I make regular content to help people with 3D printing and other projects. We now have 4 benchies and a load of data to compare. I'll start with diameter because it's the least interesting really. Whilst I did notice a very tiny increase in average diameter when the filament was soaked, there was no noticeable difference at any other time. And also the difference was so small with the wet filament that I'd happily say there was no difference at all. When it comes to weight, there are some changes. Instead of giving you the specific weights, which will get confusing as we use the filament up, I'll give you a percentage change in the material weight. From new, I was able to reduce the total weight of the filament and spool by 0.08%. That's pretty good. From all the new filament I've been testing over the last few months, I usually find that on average, I get a reduction of between 0.17% and 0.33%. Leaving the filament submerged in water for a week increased its weight by 1.4%. This may not sound like a lot, but if you put 14 grams of moisture next to a 1 kilo reel of filament, it seems like a lot more. Drying the submerged filament reduced its weight by just under 1.4%, so I'm pretty confident that all the moisture's out. So it seems that my modified S1 is capable of pulling all the moisture out of filament, which is good to know. I have a couple of videos on the mods I did to this S1 if you want to check them out. The other thing I was interested to see was whether the filament becomes brittle when it's wet. I have a couple of small amounts of filament that have been sitting around exposed for over a year and they are very brittle. Surprisingly, I couldn't notice any difference in the elasticity of the filament when it was wet. From this, I suspect that it's not moisture alone that makes your filament wet, but more a combination of moisture, temperature, and age. So now onto the benchies and an assessment of print quality. All of these benchies are printed with the exact same G code on the same unmodified Ender 3 version 2. As you would imagine, there's no noticeable difference between the brand new filament and the new filament that had been dried. Both have a very smooth hull with a few minor blobs in the same place on one side, but a couple more on the other side with a brand new filament. Both have a little under extrusion on the top of the cargo box, but other than that, the two are almost identical. I measured everything and I have to say they're so similar, I have to say there's no difference. The wet filament benchy, however, is definitely a lower quality, with increased stringing and some random blobs and imperfections. I didn't have any problems with bed adhesion and I was trying really hard to hear any popping noises. There were a couple, but nothing I could pick up with a microphone. Other than the stringing, it's not really that bad a benchy. Dimensionally, it's very similar to the other ones, except for an increased diameter on the chimney because of the rough surface. And that is the main difference I can see. All of the surfaces are just a bit worse with the wet filament and not smooth. It's clear to see the effect that the moisture has had, but it's not as dramatic as I've seen with wet old filament. Once the filament had been dried, I was really surprised to see that the quality was straight back to where it was before the filament was wet. Honestly, I was still expecting to see some stringing and some surface imperfections because I wasn't convinced that a filament dryer can actually get every single drop of moisture out. However, it certainly looks like it has. The hull is super smooth, with, if anything, very slightly fewer tiny marks than any of the other prints. Dimensions are all identical to the other dry prints, so I can only conclude by saying that, going by the test I performed, with a good filament dryer you can dry very wet PLA and bring it back to an as new or even potentially slightly better condition. I did read one theory that heating your filament up closer to its transition temperature for an extended period of time can actually anneal it and improve its quality. My filament dry box heated up the PLA to 40 degrees for 24 hours, and I'm not sure I really want to take the temperature much higher. I definitely noticed a difference in its willingness to stay wound onto the reel, so maybe there's something to this theory. The only thing I wasn't able to confirm was whether filament is able to be resurrected once it becomes brittle. This will have to wait for another video. Unfortunately, from testing, even though the filament did soak up a good amount of moisture, that alone doesn't make it brittle. Perhaps it takes a longer period of time for the polymer chains to break down, and exposing your filament to moisture for longer has a bigger effect. I also know from experience that other filaments will react differently when exposed to moisture, but again, they'll have to wait for another video. Let me know in the comments what your experience is with filament and moisture. Have you tried something similar with different results? Are you surprised by anything I found here? Click here to see how I modified my filament dryer to make it capable of pulling this much moisture out of filament, or click here for another video you might enjoy. Thanks for watching.